So database system has been a mainstream software and application program for handling and maintaining the data in computers. And besides, we have so many different data scientists in computer science have been working on this topic for many years. Here I'd like to mention Dr. Jim Gray. He is a great computer scientist from IBM Research, and he has been working on database system for many years. If you know, IBM actually has been a giant IT company for many years, even though nowadays it's not as famous as Facebook and Google now. But before that, IBM is a giant company. And so many great computer scientists have been working at IBM for many years and contribute to different areas in computer science. Jim Gray contributes a lot for database system. He has spent many times for developing and implementing the fundamental techniques in underlying and enable the online transaction process. And he also received a Turing Award for his fundamental contributions to database system and transaction process research and technical leadership in system implementation from research prototypes to commercial products. If you know, IBM has a very famous database system. It's called DB2, right? And IBM nowadays is also running a giant data warehouse for health, especially for the healthcare data for both compliance and as well as the government. And Jim Gray's work defined the key transaction properties. It's called ACID. Atomicity, consistency, isolation, and durability. They are the basic properties for the transactions. We show these different properties later in the following pages. So I hope you can remember Jim Gray for his contribution to database system in this area. And you also need to know why we have to design database system in such a way by following his scenario as well as technical contributions. In this page, I'd like to provide you with a typical transaction example. And let's assume we have an application to implement. We plan to transfer some money from saving to checking. It's a very basic operation. We use our cell phone, right? The bank account. We do the transfer of money. It is a very simple transaction actually. However, if we plan to implement this transaction, it requires the database program, right? And the process will be like this. If we plan to transfer money from saving to a checking, we have to read the saving money, right? The balance first. We'll check if the balance is enough to do the transfer or not. And in other words, we have to verify the balance is adequate or not. If it is enough, we can update the saving balance. In other words, we can deduct some money from the saving balance, and we can also read the checking. And based on the money we plan to transfer as well as the current checking balance, we can have the new checking balance, right? By updating the checking balance again. So in other words, this simple transaction may require several steps. We read saving first, verify the balance, and update the saving balance, or read the checking balance and update the checking balance. Each of these processes may also require many different SQL queries, right? Now for reading savings, we have to read by matching the user ID, right? We need to know which account we are reading. Now we can select from where, right? By writing queries like this. It will be similar for the verify, update, as well as following steps. We also have to implement them into SQL. So therefore, this simple transaction may require not so SQL queries to implement it. Here we will not show the detailed SQL queries for implementing this transaction. We just need to know the basic outlines for the DB program. It has several steps to be implemented. So when we're running our database system, we have to maintain its consistent state. What do I mean by the consistent state? So normally when we're running our system, we expect the database system state should meet our expectations. We expect the state should be like this. If this state is different from our expectations, it will be in an inconsistent state. We have to maintain this consistent state for our database system during the running time. So what can cause an inconsistent state? Normally, if we are only doing readings, the readings is fine because it doesn't make some changes to the database system, right? We know this. If a transaction only contains reads, we can expect the database system to be consistent, right? Because reads will not cause it to be otherwise. However, if a transaction contains writes or writings, we need to be very careful because if we write some data to our database systems, it may cause some inconsistent state. So where a transaction contains writes and its write finishes, it must be either committed or aborted. Committed, it means I'm done and the database system is consistent again. If everything is running successfully, then we can commit this transaction. It means it is finished and the database system right now is very good. However, if we make some problems during the running time or the execution time of the transaction, then we have to abort this transaction. This abort is also called rollback in some of the textbooks. It means I'm done, however, I make some mistakes in the running time, and everything changes will have to be undone instead. So all the transactions involving the writings will have to either commit it or abort it. In this way, we can maintain this system will be in a consistent state during the running time. I hope you can follow me, right? So read is fine, and the writings may cause some inconsistency. For the transaction involving writings, we have to either commit it or abort it. We will show details about this commit and abort in the following pages again.